Hi students, under algebra number theory, we are under unit 2, finite fields and polynomials. This is lecture number 8. So we are going to discuss the topic called as factor theorem, remainder theorem and how to find GCD. I guess GCD expansion everyone knows, greatest common divisor. So we'll move on to the outline of the PPT. So first we'll just have a look at the factor and the remainder theorems. And next is problem on monic polynomials. So monic polynomials have been already discussed in my very first slide of a polynomial. Okay, so monic polynomial is a polynomial where the leading coefficient is 1. Okay, so what is the leading coefficient? It's the highest degree term, right? So in a polynomial you will have an highest degree term, that is for example x power 5 or x power 6 or even x, whatever it is. Highest degree term, the coefficient of the highest degree term is 1, then we can call it as a monic polynomial. Okay, so the coefficient is called the leading coefficient and the coefficient is 1, then we can call it as a monic polynomial. So then we close this PPT with problems on GCD. So overview. The corollary of division algorithm branches into factor and remainder theorem. That's what's very important. So corollary is nothing but it is the extension of the theorem. So division algorithm, everyone knows it. So division algorithm, I've repeated several times in my third and fourth videos, lecture videos. So division algorithm is nothing but the dividend is equal to the divisor into the quotient plus the remainder. So from there only the corollary, the extension of the division algorithm has branched out as factor and remainder theorem. Factor theorem and remainder theorem. So here I have given you the statement of the remainder theorem and the factor theorem. So remainder theorem, let F be a field and an element A belongs to F and f of x belongs to capital F of x. Then f of A is the remainder when f of x is divided by x minus A. So I can say f of A is a remainder when f of x is divided by x minus A. That is the factor. That is the remainder theorem. Factor theorem. Let f be a field and A belongs to capital F and f of x belongs to capital F of x. Then A is the root of f of x. If and only if x minus A is a factor of f of x. That's why we write if 5 is the root, I told you x minus 5 is a factor. That is by factor theorem. So when I say A is the remainder, f of A is the remainder, then I can say x minus A was divided as being used to divide f of x. So let's get into the next slide. So first, how to find the remainder? It's a very 2 marks problem, very small problem. So to ask, repeated asked in university, Anna University. So what is the remainder when f of x is equal to x power 5 plus 2x cube plus x square plus 2x plus 3, which belongs to z5 of x divided by x minus 1. So f of x is equal to a fifth degree polynomial when f of x divided by x minus 1. So I'm going to divide this. How to divide this? So it can be divided only by the remainder, right? F of A is the remainder, correct? So the remainder will be A, right? So A is 1. X minus 1 is equal to 0. So X is A is 1. So F of 1. So I take that F of 1 and substitute here. So it becomes 1 plus 2 plus 1 plus 2 plus 3. So the answer will be 3 plus 2 is 5, 6, 7, 8 and 9. So your answer is 9. Under modulo 5, it is not perfectly divisible, but the remainder is 4. So the remainder is 4 in Z5. I will understand. So they're going to ask you for remainder. Okay. So what do you do? No need to go for division and all. You know by the theorem, it says that x minus 1 should be is a factor. From there you can get that 1 and substitute and see what is the remainder. Now second problem, what is the remainder when f of x is equal to 2x cube plus x square plus 2x plus 3 is belongs to z5 of z5 is divided by x minus 2. Same thing. What is a factor here? What is a root? 2. So what I'm going to do? I'm going to substitute 2 over there in the polynomial. Before that, let me write what is z5. z5 is starting from 0 to 4. So directly I'll substitute 2 over there and see that what's the answer is 27. 27 is also not divisible by 5. So the remainder I'm getting is as 2. So the remainder is 2 in Z5. Able to understand? It's very simple problems, can be asked for 2 marks. So problems using monic polynomials. So you know what is a monic polynomial as I give you the introduction. So first you have to identify the leading coefficient, and leading coefficient, if it is 1, then you call it as a monic polynomial. So now f of x is equal to, see, they have given a polynomial as a product of 3 polynomials. One in a cubic power, one in another in a cubic power, and the other one is a linear equation. So they have given as a product of 3 polynomials, subpolynomials, which belongs to z7 of x. Then write f of x is a product of a unit and 3 polynomials, 3 unique monic polynomials. Given f of x is equal to, it is going to be, there's a correction, 2x square plus 1 into 5x cube plus 5x plus 3 and 4x minus 1 in z7 of x. So what is z7? Starting with 0 and ending at x. To write f of x as a product of 3 monic polynomials, we have to take out 2 from the first factor, 5 from the second factor, and 4 from the third factor. Why are they saying like this? Because those are the leading coefficients here. So the highest degree term is x square. The coefficient of the highest degree term is 2. So automatically I'll call the 2 as the leading coefficient. So here also the leading coefficient is 5. Here it is 4. So unless and until if the leading coefficients are 1, we cannot call those as your monic polynomials. So what should I do for it? So 2 from 2x square plus 1, 5 from 5x square plus 5x plus 3, and 4 from 4x minus 3. So 1. So which is congruent to 8 mod 7. Now 3 is congruent to 10 mod 7. Right? No need to 4 minus 3. So f of x is equal to the product of all these given. And now what do I do? From here I can take out 2 outside, because I need to have the coefficient of the leading polynomial as leading coefficient as 2. So take out 2. So 2, if I'm going to take out, it's going to be 4. So 2 times of x square plus 4. From here, what is the disturbance? 5. Take out 5. 5 into x square plus x plus 3. Sorry, x cube plus x plus 3. From here, 4 is the disturbance. Take out 4. 4 into x plus 1. So I could see that the leading coefficients of all these 3 brackets are 1. So automatically you start multiplying 4 into 5 into 2. So 4 into 5 will give you 20. 20 into 2 will give you 40. 40 into the product of the other 3 polynomials. So automatically you had arrived at a product of all the 3 polynomials where the leading coefficient is 1. So I can call them as a monic polynomial. So before that you got to divide this 40 for the mod 7. So mod 7 is going to be closest number will be 35 and the remainder is 5. So we are writing that. You don't need to look at this. Instead of this you can write a third factor, etc. So just try to understand. Okay. So when you're going to write, see whether the monic polynomial is the coefficient of that particular polynomial should be 1. Then only we can go ahead with that particular conclusion. So now we'll move on to what is greatest common divisor, that is GCD. Let f be a field and f of x and g of x belongs to capital F of x. A greatest common divisor GCD if f of x and g of x is a non-zero polynomial d of x such that two conditions should satisfy. D of x divides f of x and g of x, and if c of x is a divisor of f of x and g of x, then c of x divides d of x. I hope it's confusing. Okay, right. Now, I just very plain and simply, I'm going to illustrate this common GCD in your problem. Okay, so you consider two polynomials. No need to worry about all this. You're going to consider two polynomials. You're going to divide one polynomial by the other polynomial. Okay, so after dividing one polynomial by the other polynomial, you will get a remainder. Is that so? Right. After getting the remainder, just check whether the remainder is a power which is greater than the divisor or less than the divisor. So if it is less than, automatically you go and divide the divisor and you can get your answer. It's very simple technique. So problem number 4. find the GCD. They are giving you a polynomial of 4th degree and they're asking you to divide by a 3rd degree polynomial over Q, they are saying. Okay, they haven't mentioned any modulo here. So so read the problem, understand the problem first, and then you can proceed. It's over just Q, rational numbers. So first I'll state what is the polynomial given to be. Right, they have given f of x and g of x, and I could see that degree of g of x is less than degree of f of x. So I'm going to by using the division algorithm. So I'm going to use repeated successive division algorithm. Then only I can land up with GCD. So what do I did? I have taken the 4th degree polynomial divided by the 3rd degree polynomial. Okay. And I have seen, see, just observe, x power 4 dividing by x cube. I'll be getting x. Take this x and multiplying, you'll be getting x power 4 minus x. Bringing down this x cube and my plus x is here, right? So now what do I do? Again divide this x power 3 by x power 3, I get 1. So put up 1 there. Take this one and multiply, I'll be getting x cube minus 1. Change the sign, cancelling it out. X is already available, right? So minus 1 is there. So what do I do? Bring down these two terms again. So it's going to be 2x square is 2x plus 2. So already an x is there. X and x will get added up and this minus 1 minus 2. So now what do I do? Now there is a divisor which is having a 3rd degree power and the remainder is a 2nd degree power. So automatically which is less than that. The power has been reduced less than that. So now furthermore I cannot divide it unless and until it is equal to or greater than, only I can proceed with the further division. So now what will I do? Since I observe that the divisor is having a greater power than the remainder, I will put the divisor here. See, parallelly, I'll be doing x cube minus 1, put it up inside and take the remainder and divide the remainder using the remainder. So if I'm going to divide using the remainder, I will be getting some numbers. Again, I get it as 0. So now what do I do? F of x. Okay, now write f of x. F of x is the 4th degree polynomial which is started with. So f of x is equal to the product of the quotient plus the divisor. X plus 1 and x cube minus 1 plus the remainder. Right. Now, how will I write this x cube minus 1? X cube minus 1 can be written as the product of these two. Product of these two, x by 2 minus 1 by 2 into 2x square plus 2x plus 2 plus the remainder. So degree of this is less than the degree of this. So you can proceed with this particular definition. So therefore, that is how I'm going to find the GCD. GCD is nothing but you divide it, use your division algorithm and write down the particular step. Furthermore, I'm reducing this and getting a remainder as 0. So I've stopped it. Otherwise, again I will repeat. So try to understand. Suppose if I have a power less than this power, suppose if I land up with x, suppose if I get x here, what will I do? I will successively go and divide this by the remainder again. So till I get 0, I'll just keep repeating unless the power is less than that. And finally, I conclude the problem by saying f of x start with the original equation given, and from the product of that, and that further product is product of the other two, and further how many times you have repeated. Able to understand. Therefore, the GCD is x square plus x plus 1. Okay, how did I get this? This is the common term after substituting in 2x this value, right? Substituting here, the common term is x square plus x plus 1. Therefore, the GCD is x square plus x plus 1. GCD is greatest common divisor. So we could see that which term is divisible by that. Thank you so much for watching the video. I hope everyone understood. So we'll just have a recap of all the 8 topics what we have studied so far. Okay. So first lecture, we had discussed what is a polynomial. A polynomial is an algebraic equation where you have a single variable raised to any power. Necessarily, it should not carry negative powers and it should not carry square root terms. How to find the degree of a polynomial? The degree of a polynomial can be found by the highest degree, that is highest term, that is highest power term. Whichever term is having the highest power, that will be called as the degree of that particular polynomial. Right? if the particular highest degree term, the coefficient of the highest degree term will be called as your leading coefficient. Then suppose if the leading coefficient term is 1, then I can call it as a monic polynomial. And then again we have a constant polynomial, we have a zero polynomial, etc. Okay. So likewise we had seen this in the lecture 1 video. Lecture 2 video. Lecture 2 video was discussing how to find the roots of the polynomial. So roots of the polynomial without mentioning the modulo means it's very easy for us to just equate it to 0 and get the roots. Suppose if the modulus is given, so you have to mention the modulo elements and one by one you got to substitute inside the polynomial, and if the remainder is 0, then I can call that particular element as a root, or else it is not a root. And if it is a root, I can say x minus 1 is a factor of that. This was the 2 lectures under polynomials, degree of polynomials and roots of polynomials. Third and fourth lecture was discussing about division algorithm. So division algorithm was framed by the famous mathematician Euclid, where the dividend is equal to the product of your divisor and the quotient plus the remainder. So necessarily a very important thing which have to be mentioned is the divisor should not be equal to 0, right? Then after this you got to go and find out how you use division algorithm under modulo. So divide one after the other and you just find out the remainder. The remainder is equal to 0. That particular term will get vanished, or else we got to continue further and further on. Okay, and the lecture number 5, lecture video 5 and 6 was discussing about irreducible and reducible polynomials. So what are reducible and irreducible polynomials? If a polynomial f of x can be written as a product of two other polynomials with lower degree, then we can call it as a irreducible. Then we can call it as a reducible polynomial. If not, we conclude it as a irreducible polynomial. Clear? So now after finding irreducible and irreducible polynomial, and the next section was talking, next video was talking about, we had a discussion how to find these product polynomials equal to 0 and not equal to 0, and how to find reducible polynomials, how to construct reducible and irreducible polynomials on our own. So these things we have learned. And next comes few theorems, division algorithm theorems, Euclidean domain, finite field, etc. Please go through the theorems also. And now in this last lecture, that is the 8th video, we had seen what are factor theorem and remainder theorem and how to find GCD. So it's just by mere argument saying that if A is a root, then I can say x minus A is a factor. If x minus A is a factor, then I can say f of A is a root of that. So likewise, you please revise topic by topic, and if there is any doubt, we can clarify it in the Google Meet. Okay. Thank you so much for watching. I hope you understood the second unit, finite fields and polynomials. Thank you. Signing off, Henrietta.